The next topic we will be discussing would be about the structure of matter. First of all, we will be looking at the structure of ionic compounds. If you look at first of all this diagram, this basically shows that the positive ions, let's say these are the positive ions and these are the negative ions. Positive ions and negative ions are basically held together by strong electrostatic force of attraction. Since there is a strong force of attraction which is electrostatic, there is a formation of giant lattice structure. Due to this formation of giant lattice structure, there are certain properties that the ionic compounds have. First of all, ionic compounds, they have very high melting points and boiling points, extremely high melting points plus boiling points. This is primarily because a lot of energy is required to overcome the strong electrostatic forces of attraction holding the ions in the lattice together before the compounds can melt or they can boil. As seen in this diagram, there is a lattice and there are positive ions and then there are negative ions, and between the positive ions and the negative ion there is a very strong electrostatic force of attraction. So in order to overcome this force of attraction, in order to melt it or boil it, you need to have a lot of energy, you need to provide a lot of energy to overcome this strong force of attraction which holds the ions in the lattice together. Now, due to their high melting point and boiling point, ionic compounds are usually found as solids at room temperature and pressure. Again, if I repeat this point, why do ionic compounds have high melting points and very high melting points and very high boiling points? Because there is a very strong electrostatic force of attraction between the positive and the negative ions. So in order to overcome that force of attraction, there is a lot of energy required in order to overcome that force, in order to melt the compound or boil the compound. And due to this high melting point and boiling point, these ionic compounds are usually found as solids at room temperature and pressure. Now the other thing is that the melting point and the boiling points are influenced by the strength of the electrostatic force of attraction. Let's say that magnesium oxide has a higher melting point than sodium chloride. Why? Because the ions in sodium chloride have charges +1 and -1, right? While the ions in the magnesium oxide have charges of 2+ and 2-. The electrostatic force of attraction are stronger in magnesium oxide, hence more energy is required to melt it. Let's look at this example again. Here we have an ionic compound of sodium chloride in which we have sodium ions and chloride ions. And another example of an ionic compound is magnesium oxide, which has magnesium ions and oxide ions, right? So as you can see that there is a charge of 1+ and